Good afternoon. We will continue multivariate descriptive statistics today. Last class I have given you SJK, the formula to compute the covariance between two variables xj and xk, and this is the sample covariance computation formula. Now, we want to use matrix here, primarily matrix multiplication to compute S, where S is this one, that P cross P matrix, diagonal elements will be the variance component and off diagonal element will be the covariance component. We will compute this from the data matrix. Thus, data matrix, last class you have seen the data matrix like this, that x 11, x 21, like x I1, x n1, that is observation on variable x1. Similarly, observation of variable x2 is x 12, x 22, like x I2, then x n2. So, you take all p variables, then x 1p, x 2p, x ip, and like this x np. This is our n cross p matrix. Now, let us consider a general observation here, which is x I j. So, if we create one more general observation x star I j, which is x I j minus x j bar, then the resultant if what you do, if you subtract each of the elements by its respective mean. For example, for this one, if you subtract by x 1 bar, for this it is x 2 bar, like this it is x p bar, then you will create another matrix which we are denoting like this. X star is your x star 1 1, x star 2 1. So, like this x star n 1, x star n 1, then x star 1 2, x star 2 2, like this x star n 2. So, x star 1 p, x star 2 p, like this x star your n p. Okay. Now, if you create this x star transpose, what will be the order of this matrix? P cross n, and take a dot product with x star, This resultant matrix n cross p, resultant matrix will be a p by p cross matrix, okay, which is nothing but n minus 1 into S, where S is the covariance matrix. So, S is p cross p, that is the covariance of x, where you have taken this, calculated this x. Okay. So, in matrix manipulation, you are able to find out the covariance matrix in just one go for all the matrices, all the variables. Okay. Now, you solve one problem, small problem here. For example, suppose this one, you see that you take this one, that first 10, 12, 11, 100, 110 and 105, this data matrix. x equal to 10, 12, 11, 100, 110 and 105. So, what will be your x 1 bar, or if I say x bar equal to x 1 bar and x 2 bar, what will be its value? It will be 10 plus 12 plus, that is 13 by 33 by 3, 11, and this one will be 100, 110, 105. 105. Now, what you are creating? You are creating x star. What is this x star? You want that each element on x 1 will be subtracted by its mean 11. Similarly, each element of x 2 will be subtracted by its mean 105. So, then this one will be 10 minus 11, 12 minus 11, 11 minus 11. Second one will be 100 minus 105, 110 minus 105, 105 minus 105. What is happening here? You are getting, this is 10 minus 11 minus 1 plus 1 0, then 100 minus, that is minus 5 plus 5 0. This. So, essentially that 0 is element is coming here. Okay, let us see that what will happen if we do like this, x transpose x. What will happen here? Minus 1 1 0 minus 5 5 0 multiplied by a x star minus 1 1 0 minus 5 5 0. If you multiply, what will happen? This is basically 2 cross 3 matrix, this one is 3 cross 2. So, we want to get matrix called 2 cross 2. So, this time this minus 1 into minus 1, minus, that is plus 1 plus 1 plus 0. So, what will be this 2. Now, second one minus 1 into minus 5, that is plus 5, 1 into 5 plus 5, that is 10. So, this one minus 5 into 1 minus 5, 5 into 1 5, 5 plus 5 10, and this one 25 plus 25, that is 50. Okay. So, we say n minus 1 into s equal to x star transpose x star. So, which is here 2 10 10 50. So, what is n value here? 3, n is 3. So, n minus 1 is 2. So, s will be 1 by 2 2 10 10 50. Then what is this value now? Our s is, that means 1 5 5 25. So, you have already computed x bar, which is your 11 105, and your s is this. So, that means s 11 is 1, s 22 is 25. What does it mean? S 1 square equal to 1 and S 2 square equal to 25. So, S 1 equal to 1, S 2 equal to 5, that is the standard deviation, both the cases, and S 1 2, which is 5, the covariance between x 1 and x 2. Okay. So, if I say that my population is normal population, multivariate normal, that is 2 cross 1, this is the variable. So, it is basically n 2 mu and sigma, then my mu is mu 1 and mu 2, and sigma will be 2 cross 2, sigma 1 1, sigma 1 2, sigma 1 2, sigma 2 2, this is 2 cross 2. So, we can now say this is our x bar, the estimate. Yes, in this manner we will proceed. Okay. So, that means please remember multivariate descriptive statistics has 3 component. One is mean vector, second one is covariance matrix, third one is correlation matrix. Correlation matrix. Now, we will discuss about correlation matrix. Now, population correlation matrix is denoted by rho. This is population correlation matrix, correct. If there are p variables, basically what I mean to say that if the population is characterized by p variable, then you will get p cross p matrix for the population correlation matrix, like p cross p for some population covariance matrix. The beauty here is that your diagonal element will be 1. Diagonal element will be 1. This is the correlation of the same variable with it, and off diagonal element will be writing like this, rho 1 2, like rho 1 p, here also rho 1 2, rho 2 p. So, like this rho 1 p, rho 2 p, it will continue like this, correct. Now, if this is the case, can we find out a relationship between rho and sigma? What is sigma? Population covariance matrix, that we have seen sigma 1 1, sigma 1 2, sigma 1 p, 1 2, sigma 2 2, sigma 2 p, like this 1 p, sigma 2 p, sigma p p. So, the crux of the matter is the diagonal elements are variance, that is means the same variable varying with it, that is the case. Similarly, here diagonal element is the correlation. Okay. So, if you see what is the correlation between x j and x k, then you can write this one as covariance between x j x k by standard deviation of x j times standard deviation of x k, deviation of x k. So, mathematically what we write basically mathematically, that correlation of x j x k is cov of x j x k divided by sigma j sigma k. Now, you have seen from this figure, we are saying that correlation between j and k is somewhere like this, rho j k. Here also we are talking about that covariance between this is this, like this. So, then if I use the same notation, I can write rho j k equal to sigma j k divided by sigma j sigma k. That is the relationship. What is the relationship then? Covariance between two variables is the correlation between the two variables times its standard deviations. Correct. Now, what will happen to this correlation when sigma j, when j x j equal to a, what I mean to say, j equal to k? You see what will happen to this? That means it will be j j, j equal to j j, then sigma j j by sigma j sigma j, and we have discussed earlier that sigma j j is nothing but sigma j square. So, that by sigma j square, which is 1, and as a result you are getting all 1. Okay. So, conceptually that the same variable you are trying to find out the covariance between the same variable, then that will be give you the variance, and here what you are doing, you are basically standardizing it by dividing the standard deviation to the covariance component. So, as a result the standardization effect is bringing you that all the diagonal elements will be 1. Okay. The same thing will happen for sample data also. Now, what do you mean by, suppose correlation between j and k is plus 1, correlation between j k is minus 1, correlation between j k is 0. Okay. This one is saying that perfectly correlated, positively correlated, and 1 stands for the perfect correlation. This minus stands for negative. So, that means that is positively correlated, this is negatively correlated, this one is having no correlation, positive, negative and no correlation. And if you draw this, suppose you have two variables, this side suppose x j and this side x k, and if you draw scatter plot for positive correlation, you may get like this, that is rho j k equal to 1. Okay. And negatively correlation means x j will increase, x k will decrease, or vice versa. So, you can think like this. Here what is happening? In this case, this rho j k equal to minus 1, assuming that all the values of x j and x k falling on this line. That is why negative. That means, here when x j is increasing, sorry, x j is increasing, y j x k is decreasing, and in this case when x j is increasing, x k also increasing, all are falling under the curve. Positive is possible, one positive possible when it will increase, both the variable covary in the same direction, negative means in the opposite direction, and 1 is possible when you will find a perfect straight line if you do curve fitting, and when you will get 0, suppose your points are like this. This is your x j, this y axis is x k. Points are like this. You cannot find, it is just like a resemble a circle. These points are resembling a circle, it is totally random. So, when you find this type of randomness, that means it is basically resembling a circle. There is no relation, because you see, you take any direction, you will not get any pattern here. So, that is the meaning of correlation coefficient like rho j k. You convert it into the same, how do you calculate? You have data set like x, where same data set n cross p, and I have already given you that we have converted this x star where each of the observation was subtracted by its mean like this manner, n1 minus x1 bar, n2 minus x2 bar, np minus xp bar. This was we created earlier, and here we created one general xij. Here also we have created that xij star, where x star ij is xij minus xj bar. Now, let us create another variable. Let us write like this: x tilde ij. This one is xij minus xj bar by sj. What are you doing? You are first finding out the mean subtracted values, then dividing it by the corresponding standard deviation. I can write it like this: xij minus xj bar square root of sjj. Okay. If you follow this, then you will create a matrix which is x tilde. This one will look like this: x 1 minus x 1 bar, this divided by s 1 square root, then x 1 minus x 1 bar divided by square root of s 1. Same manner, all the observation in the x variable is x n1 minus x 1 bar divided by square root of s 1. For x 2, what you will do? X 12 minus x 2 bar divided by square root of s 22. X, this is 22 minus x 2 bar divided by s 22, like this x n 2 minus x 2 bar divided by s 22. So, if you go in this manner for pth variable, then you will write x 1 p minus x p bar divided by square root of s p p, then x 2 p minus x p bar divided by square root of s p p. Same manner, x n p minus x p bar divided by square root of s p p. This is a transform data matrix P cross P. All are, when it is x 1, all will be 1 1, x 2 all will be 2 2, when it is P all will be x P P. See, the similarity is all these are x 1, when each observation is subtracted by the same mean vector of the variable 1, and each that resultant quantity is divided by square root of s 1. Similarly, here x 2 bar square root of s 22. Similarly, here x p bar square root of s p p. Okay. So, you see that earlier ultimately if you see the covariance and correlation relationship, you have found out that, see, Jk, when you say Jk, we basically the covariance component is divided by the corresponding standard deviation. So, in order to achieve this, what we are doing here, we are now dividing each of the observation by the corresponding standard deviation. Then now, if you find out this one with this, so x transpose, then it will be p cross n. If you give a transpose here, x tilde transpose, dot product, if you do x tilde, that will be your n cross p. So, the resultant quantity will be your p cross p, getting me, p cross p. Then what will happen? No, this will not be identity matrix. This is not identity. You see, you will get this one as n minus 1 into r, n minus 1 into r. Okay. If you want to check it, you check it very simply. Suppose my data matrix is like this. I will take only 3 values, x11, x21, x31. Then here the second variable you take x12, x22 and x32. So, in this case the data matrix is 3 cross 2, where n is 3 and p is 2. Okay. Then what you are creating here? You are creating x tilde. What is this? This is nothing but x11 bar minus x11 minus x1 bar by, I am writing s1 only, with instead of square root of s11, that is s1 I am writing. Then this will be what? x21 minus x1 bar by s1 and x31 minus x1 bar by s1, and this will be x12 minus x2 bar by s2, then x22 minus x2 bar by s2, then x32 minus x2 bar by s3. What will happen? If you now do like the another, yes, this is s2. Keep in mind the variable and accordingly write down this one, okay, s2. So, then if I do like this x tilde transpose x tilde, what will happen? Your x11 minus x1 bar by s1, x21 minus x1 bar by s1, x31 minus x1 bar by s1, and then this one will be x12 minus x2 bar by s2, x22 minus x2 bar by s2, x32 minus x2 bar by s2. This times you will be writing the same thing, x11 minus x1 bar by s1, x21 minus x1 bar by s1, x31 minus x1 bar by s1, then here x12 minus x2 bar by s2, x22 minus x2 bar by s2, x32 minus x2 bar by s2. This one is 1, 2, 3. So, 2 cross 3, this is 3 cross 2. You see this into this plus this into this plus this into this. What is happening here? x11 minus x1 bar by s1, x11 minus s1 bar by s1. This you are getting a square. So, what you are doing then? You are basically getting sum total. If I write I equal to 1, 2, 3, because our observation is 1, 2, 3. Now, second one stands for the variable. So, x I1 minus x1 bar divided by s1, that square you are getting. Okay. Then what will be this one, this cross this. Now, this cross this, what will we get? x11 minus x1 bar, x12 minus x2 bar. You see what you are getting here? You are also getting I equal to 1, 2, 3 x I1 minus x1 bar divided by s1 into x I2 minus x2 bar divided by s2. Same quantity you will be getting here, I equal to 1, 2, 3 x I1 minus x1 bar by s1 and x I2 minus x2 bar by s2. Here you will be getting a square term, I equal to 1, 2, 3 I2 minus x2 bar by. Getting any similarity here? Any clue are you getting? You see, we say what is a sum total of, if I ask you what is S1 square? Suppose n equal to 3, then what is S1 square? 1 by n minus 1, sum total of I equal to 1 to n x 1 or x I 1 you write minus x 1 bar square. S 1, you see what is happening, x I 1 minus x 1 bar square 1 by n minus 1. So, this quantity is what? N minus 1 into S 1 square. So, and yes, because S 1 by S 1 is coming. So, ultimately what will happen? Ultimately you will get this quantity like this, that we can write n minus 1 means here 3 minus 1, 3 minus 1 into S 1 square by S 1 square. Then second one, what will happen? This is the covariance, yes or no? N minus 1 you will get S12 by S1 S2, that is n is 3 here. So, 3 minus 1 S12 by S1 S2, and then this one also you get 3 minus 1 S2 square by S2 square. Then if I just take out 3 minus 1, which is basically 2, then what I will get? I will get 1 S12 by S1 S2, S12 by S1 into S2 and 1. And as a result, what we are writing? This is n minus 1 r, n minus 1 is 2, that means this is 2 r. Now, 2 is to cancelled out. So, r is now 1 r12 r12 1, which is now 1 S12 by S1 into S2, then S12 by S1 into S2 into 1. Correct. And we have seen earlier, I think we have seen earlier that the correlation and covariance, the relationship, we have seen earlier the relationship what? In population domain, we said this one I have said to you, this as well as this. Now, instead of rho in the sample domain, what you can write? You can write Sjk equal to sigma jk by sigma j sigma k. Now, if your j equal to 1 and k equal to 2, then it is S12 equal to sigma 1 2 by sigma 1 sigma 2. What is exactly happened here? This is not Sjk, this is basically rho jk. This is rho jk, then this will be your rjk. Rho jk is, this is basically replaced by sigma, and then it will be like this. So, if I can write rho jk here, rho 1 2 like this one. Now, in the sample domain when you go, that will be your r 1 2 will be your S 1 2 by S 1 into S 2. That is why this R12 is S12 covariance by their corresponding standard deviation. Okay. So, for the same data set, can you now compute this your R value? I think we have computed one place. R value we have computed. Yes, we have computed here. We have seen S equal to this. Okay. So, that means your standard deviation S1 is given and S2 is given. Now, for the same data, if I want to compute my R, then what will be your R value? Your R value will be, first, that blindly you can write like this, diagonal element will be 1 and R12 will be S12. So, S12 is 5. So, you can write 5 divided by their standard deviation. S1 is 1, S2 is 5. So, that means 5 by 5, 5 by 5, 1, 1, 1, 1. Oh, you are getting perfect correlation. 1 means perfect correlation. So, this is what that your in multivariate descriptive statistic we will talk about. That is why the mean vector, correlation matrix and covariance matrix. Now, you can very easily convert this one. Suppose my covariance matrix is this S11, S12, S1p, 12, 22, 2p, like S1p, 2p, pp. My correlation matrix is this 1, R12, R1p, R12 again 1, R2p. So, like this R1p, R2p, 1. So, you create another matrix, diagonal matrix D, S. This one is same P cross P matrix. This is P cross P, this also P cross P. Same P cross P matrix, only the diagonal elements will be the variance component of diagonal element will be 0. So, this is S11 0 0 0, 0 S22 0 0, like 0 0 0 0 S P P. So, only diagonal elements are the diagonal elements of DS are the diagonal element of the covariance matrix. Of diagonal elements are 0. If you create like this, then suppose you know S, you can just with one click you can find out that R is ds to the power half S ds to the power minus half, both case minus half, ds to the power minus half. If you use MATLAB, you give this MATLAB now straight away will calculate all those things from the data, but suppose you want to do the conversion, even in Excel also you can do this. Getting me? What you are doing? You most of the time you may be knowing this one, that variance component. Once you know S, you know the variance covariance also, you want to calculate R. Suppose you know this variance component are known and correlation is known, correlation matrix is known, you want to go to covariance matrix from correlation matrix. What you have to do? You have to write like this, plus half. So, this one, this is basically from covariance to correlation, and here correlation to covariance. Only thing you want to require in the second case, the variance component of all the variables considered. Okay. Another important concept in multivariate data analysis is sum square and cross product matrix. Sum square and cross product matrix, which is known as SSCP, sum square and cross product. Okay. So, if you see the when you calculate the covariance matrix, correlation matrix, we have used the formula x, that one for n minus 1 cross S equal to x star transpose x star we have used. We have used n minus 1 r equal to x tilde transpose x tilde we have used, where both x star and x tilde are basically transpose not transpose transformed matrix from the original data, which is x. So, if x is now suppose x I am writing like this x 11, x 21, x 31, x 12, x 22, x 32, you do like this. Now, you calculate x transpose x, what will happen here? You will be getting like this x I 1 square I equal to 1 2 3. Here the I equal to 1 2 3 x I 1 x I 2. Here I equal to 1 2 3 x I 1 x I 2. Here x I 2 square I equal to 1 2 3. I have taken 3 cross 2. If you multiply, you will be getting this, because earlier we have seen subtracted by mean and for divided by standard deviation case, we have seen we got similar formula. Now, the same thing if you think from the p cross p variable point of view, then x transpose x will be a p cross p, because x transpose this one is p cross n and this one is n cross p, you will be getting like this. So, your matrix will be like this, sum total x I 1 square, then x I 1 x I 2, then your x I 1 x I p. Here x I 1 x I 2, here x I 2 square, then x I 2 x I p. In similarity, I am writing all those things x I 1 x I p, x I 2 x I p, then x I p square. Okay. So, it is a p cross p matrix. Correct. Then I equal to I definitely equal to 1 to n, all cases. One to n. These three matrices like x transpose x, x star transpose x star, x tilde transpose x tilde, these are all sum square and cross product matrices, all SSCP. Why? You see now, these are the sum square, all diagonal elements are sum square, and off diagonal you see cross product, all off diagonal are cross product. So, sum squares for the variance, cross product for the covariance. So, that means from this matrix also, once you know this, you can we can go from the we use this or this matrix, but ultimately we can calculate the descriptive statistics like covariance and correlation matrix. This one is very important matrix. Later on, particularly in regression, you will be using this matrix. Now, let us see that how to calculate. Suppose this is the problem given, okay, that compute S and R for the data given. This data set you have seen earlier. So, I have used Excel only. Using Excel I have created. So, this is my data matrix. I want to compute the mean. Then as there are n data points, so I created one unit vector with n data points. So, my n is 12 here. So, it is 12 cross 1 vector. Then x bar is 1 by 12 x transpose 1. When I multiply all those things, I got these values. So, profit mean is 10.67, then sales volume 102.75, 7.92 is your absenteeism, then breakdown 59.33 and 1.06 is the that M ratio case. So, your first step will be this, find out x bar, and you use this type of formulation. Then what you require to calculate? You require to calculate S. You require converting this x value to x star. That means each of the, suppose 10 minus 10.67, that is why minus 0.67 is coming here, x star. Once you get this, this is the formula, S is 1 by n minus 1, x star transpose x star, this will give you this value. Okay. So, if you calculate on the left hand side, the bottom portion, this is nothing but SSCP matrix, x star transpose x star. You can do the same thing now. We are interested to know that tilde. Here this is basically x tilde, this one x tilde transpose x tilde, this transpose part is missing, x tilde transpose x tilde, and R is 1 by 11 into x tilde transpose x tilde, you are getting like this. You see, once you go by this way calculating, you will be getting all the diagonal elements 1. If you do not get that, there is a problem. You have any questions so far? Okay. Now we will go to, although next class I will be explaining in detail, when we will start that multivariate normal distribution. What we have assumed here? We have assumed here is x, that is a variable vector x1, x2 dot xp, that is p cross 1, and we assume that this follows normal distribution, that is multivariate normal, which will be denoted by like this np and mu and sigma. Okay. Now, you are well accustomed with the nomenclature, in the sense you know that mean is mean vector. If there is p cross 1 variable, then my mean is again p cross 1, that is mu 1, mu 2, mu p. And you also know this one, this is nothing but covariance matrix. So, this covariance matrix is our p cross p matrix, sigma 1 1, sigma 1 2, sigma 1 p, sigma 1 2, sigma 2 2, sigma 2 p, sigma 1 p, sigma 2 p, sigma p p. Multivariate normal distribution is characterized by p variable with parameter, that is mu, that is a mean vector, and covariance matrix, correct. So, please remember these are population parameters, these two are population parameters. So far we have not discussed about that whether the data is coming from multivariate normal or not, but ultimately we will be going to multivariate normal distribution, because most of the models that will be rely on this assumption, multivariate normality. Okay. Now, when p equal to 1, that is univariate normal. Now, what is the definition, probability density function of univariate normal? Suppose x is a random variable which is univariate normal with mu and sigma square. Then, if I want to know what is your probability density function of x, this is your f x PDF. You will write 1 by root over 2 pi sigma square e to the power minus half x minus mu by sigma square, where minus infinite less than x less than plus infinite, correct. So, this is what is some you have seen earlier, that this is what our normal distribution is. Normal distribution is. So, what will be the equivalent distribution when number of variable is more than 1? That will be our starting point in the next class. Okay, then, thank you.